Ocean Field Trip!
I'm Emma. I'm Chloe. I'm Amelia.
I'm Adam.
I'm Abby. We are in the ice tunnels.
The waterfall.
We are now making a new hole for a new wire to go down. So I'm using gas to heat up 20 litres of water. It's going to drill down 10 metres.
Over the past 6 months, the ablation rate has reduced by 9 metres.
As the ice melts, the hose is dropped into the hole. We're on the Mid-Atlantic Ridge. We are measuring the distance between the two plates. To our right we have the North Atlantic Ridge, to our left we have the Eurasian plate.
And Adam.
Which moves far at a rate of roughly 2.5 metres per year. We are at Logbook, which is behind us here. It was founded on the Parliament in AD 930.
The Parliament was known as the Althing and was the session for the Vikings to create laws, even though they didn't have any written.
We're in the national park and we're removing the saplings from the coniferous trees because they want to stop the plantations. It's to stop them attacking the natural flora as well. Every time we find one, we're gonna be marking it as a waypoint on the GPS, and we will be taking out the ground carefully to stop the disturbed habitat and putting it in this bag.
And it's helping because there are an invasive species in the area and they're trying to get
Forests were planted in the last century because the whole area was overgrazed, so they wanted to plant some trees, but now they've gone back on that idea and they want to just have the native species.
Removing a tree, but it's a very big tree. This is our findings on our over a kilometre walk, which took about 3 hours. I think we ended up picking 13 trees.
Good question, because of course there's on one hand, just the cutting down doesn't take very long, but it is the process of making this decision basically. On one side, which really want to get rid of the forest as soon as possible, and on the other side you have people like, well, we did a lot of work, to grow something in a country where usually we don't have many forests, so maybe we should keep what we have, and therefore, we try to find a balance between the two.
We're here today at the Iceland Large waterfall, which is approximately 60 metres high. We're going to do some measurements measuring conductivity, temperature and pH. Watch us!
We're climbing Elfell. Behind us you can see lichen on the rocks.
Which we'll also be measuring and comparing with ones found in the church graveyard.
We're also going to be measuring the temperature of the ground all the way up to Elfell.
And we'll also be monitoring how much new land was created during the 1973 eruption.
We are measuring the diameter of the lichen and the area it's covered to distinguish the age of the lava.
We've just discovered a sign on our walk up to Eldfell, and it describes how the building used to be on this site during the volcanic eruption in 1973. However, it is now located 40 metres underneath where we are stood.
Geologists use 6.2 million tonnes of seawater to flow through imported powerful pipes to prevent the lava flow after the eruption hitting the harbour mouth and the town, and it was a success.
Just discovered a sign that helps explain the devastation the 1973 eruption caused. As you can see here, there was plenty of houses in this area. Now if we look behind the sign, all destroyed, all gone. Doing a bit of quick math, I have figured out that the land mass has increased by 19.6% after the eruption.
We've
conquered Elfell! We're at Sultan today.
The hydrogen sulfide interacts with minerals in the soil, creating this landscape of orange and green and blue.
The gases also percolate into the rocks and changes its structure, making it weak and more like a clay and mud-like consistency.
These hot springs, mud pots and fumaroles reach depths of 1,000 metres and temperatures of 80 to 100 degrees Celsius.
When precipitation occurs, water infiltrates into the groundwater and infiltrates downwards towards the magma chamber, and then when it reaches close towards the magma chamber, the water heats up and also collects various metals and gases, and then when it rises again, It will then be dispersed into hot springs, as you can see here, or fumaroles.
Here at the Viking settlement, surrounded by a lava field, which formed in 1151 AD when a fault erupted. And as you can see, the lava is very deformed and jagged on top, and moss has grown on top of it.
It's still unknown why the lava flow decided to go round the settlements that used to be here. Scientists are still baffled, just as baffled as we are.
We're in Donovan, we've got a funeral.
The fumaroles are used for geothermal energy, which heats homes and other buildings.
However, it produces hydrogen sulfide into the atmosphere and arsenic into the ground. Behind us is Iceland's deep drilling project. They produce a lot more geothermal energy than they need, so they can sell this to other countries and benefit through their economy.
A negative of the deep drilling is that the deep drilling can cause earthquakes, which then may set off a volcanic eruption.
We are in the 5,000-year-old lava tunnel. It formed in the eruption when the outside cooled and then molten lava flowed through them.
You can see the lava flows on the side and how they decided to solidify at different times, creating lines.
There's also a strong colour of red, and that is the oxidation of all the iron particles in the magma.
And the only living thing in here is bacteria, which you can see, it looks white.
We are at the geothermal power station, which is located on top of the active volcano of Hengel, which last erupted 2,000 years ago. It produces 300 megawatts of energy per year.
They have two boreholes in the power plant, one that abstracts water and one that abstracts steam. The steam is then turned into a vent, and as you can see behind us, they actually remove a lot of the steam to make sure the steam is nice and dry. When the steam is dry, it is then passed through a turbine, which then creates a lot of electricity, which is then put into a generator, which is then fed to the community. The water that is abstracted goes through a very large system of heating and cooling, and then once it's finally heated to its desirable level, it then goes in through various generators which remove the undesirable gases such as carbon dioxide and sulfur, and then stored in a hot water tank and then delivered to the community.
The pipeline is 27 kilometres and it runs all the way to Reykjavik, all the way up here, to Perlam. The hot water is then used to heat homes and 22 swimming pools in Reykjavik. It also heats up streets in winter, so that when the snow falls on the ground, it just melts off straight away.
A benefit of geothermal activity is that it makes electricity and heating very cheap in Iceland, whereas most things are very expensive and it's renewable. And they also make enough energy that they can pump it to other countries. And the UK is going to start getting their electricity and heating from Iceland.
Post-Brexit.
A negative of this is that they have to remove the toxic chemicals of carbon dioxide and hydrogen sulfide manually.
Another negative is that it's a closed system, so the system doesn't naturally recharge, so they have to re-inject the geothermal brine at the right pressure to be able to keep the system going. We're at the geyser!
The water infiltrates into the groundwater through pores and aquifers until it meets the rocky surface.
As the water boils, the increase in pressure creates columns of steam and water which burst through the Earth's surface.
A geyser is a small hole connected to multiple long narrow tubes, and the longer the tube, the higher the pressure and the longer the eruption time.
This is the Great Geyser. When it goes off, it's up to 60 to 80 metres high, however it's very infrequent.
Compared to Strokka over there, which goes off every 6 to 8 minutes.
Wow, it's massive!
The river carving out the soft rock through the hard rock. There's a lot of erosion here, lateral, vertical, and probably some weathering as well.
We are in a geothermal greenhouse. The main geothermal energy has been used in greenhouses like this in Iceland since 1924.
The construction behind me shows the mantle plume beneath Iceland. As you can see, Iceland's at the top and it's very small compared to the mantle plume.
It's 15 to 20 million years old, and it's the reason that Iceland is the only country along the Mid-Atlantic Ridge.
I'm currently looking at some information displayed at the lava centre about the Iceland volcano. The volcano itself is a low-angle stratovolcano with a large top crater. There's a glacier situated at the top, so when it erupts we do get a very large flow of water coming down the mountain.
We're at the settlement exhibition and find out how the Vikings lived. The museum's key features are a timeline and panoramic view of how they lived. They also have a real 10th century hall which was excavated in 2001. The museum's actually built around it.
The reason this exhibition is called 1871 plus or minus 2 is because they can use the eruption of Thorgelson to date the tephra deposits and using Iceland ice cores in Greenland to specifically date where the settlement was made. Guys, this is our final video. How was your impressions of Iceland?
It was